Hey folks, I wanted to give you hopefully just a 10-minute or so overview of this first lab that we're doing. Was wanting to get this done earlier, but hopefully this will help some of you that haven't done it before or haven't done it yet. We just want to kind of quickly walk through the example that we've got, as well as some stuff that'll help hopefully with the second part of it, and hopefully that'll help you get the lab done. So you're going to need a compass. Here's one example of a compass. You may have something like this at home. If you don't have a compass, you can take a pencil and just tie a piece of string to it and hold one end of the string down and use that to draw a circle. You want to draw a pretty good sized circle on a piece of graph paper. I'm going to use this smaller circle in the example that's in the eLearn module. That'll just help us get the numbers smaller and will help us see a little bit better where the numbers come from for the first part, where we're doing the area, using the area and the radius squared to get the size of the circle. And sorry, not the size of the circle, but get pi from the size of the circle. So you want a piece of graph paper, and you want to draw again as big of a circle as you can on the piece of graph paper. And you want to have the point of the compass where the middle of the circle is on one of the crosses of this circle. So right there where two of the pieces cross, preferably in the middle, so you have as much space over on one side as you do on the other. And you want to, as best as possible, let the edge of the circle come out to one of the places on the horizontal line going through it, where it catches one of the vertical lines. So you go like a full number of boxes and not like halfway out to the next box or halfway short of the next box. So you want to go, in this case, we've gone out 1, 2, 3, 4, 5 steps. 1, 2, 3, 4, 5. So that gives us the radius of the circle here, right? So I'm going to pull up the data sheet, or just a copy of the data sheet that y'all will be working with. And so for this circle, we would have a radius of 5, right? Okay. Yours should be a lot bigger, assuming you have reasonable size squares on your graph paper. Then the next thing we want to do is we're going to estimate the area of the circle by counting the squares that are completely inside the circle. So these squares here that are in the darker gray, they've got part of the square outside the circle, so I don't want to count them. I only want to count the squares that are completely inside the circle. So these right across here, these across here, across here, across here, and then the same thing underneath. To make life a little bit easier, I realized that the circle is the same on all four quadrants. And so I'm just going to count up the squares that are completely inside the circle in this first quarter circle, and then I'll multiply that by 4. Okay. So if I look at this, these light gray ones right here are in the top right quarter of the circle, and they're completely inside the circle. So if I count those, here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's where it gets this idea. There's 15 boxes completely inside the circle in that upper quarter circle, right? So there's 15 here, there's 15 there, 15 there, and 15 there that are completely inside the circle. And so 4 times 15 would give me 60. So there's 60 squares, or an area of 60 that's completely inside the circle. So I'm going to go over to my data sheet. I'm going to put 60 as the area inside, right? And then I'm going to calculate pi from that. And we saw in the write-up that pi is equal to the area of a circle divided by the radius squared, right? The radius times the radius. And so for this first measurement, the inside pi, which again is from the area inside the circle, is going to be 60, which is the number of squares inside, divided by the number of squares in the radius, which is 5, but I've got to square that radius. So that's 60 divided by 25. And I don't have my calculator real handy, so we'll just go back here and look and see what does that say. 60 divided by 25 is 2.4. Okay. So with those measurements, I would arrive at an estimated value for pi of 2.40. Okay. Now we know that's too small because pi is actually the area of the full circle divided by the radius squared. And we know that we're missing some of the area, right? Particularly right through here, all these partial squares, right? So we know that this is an underestimate of the value for pi, but we'll go ahead and take it. We know that pi is something bigger than 2.40. Okay. Okay. So that's our first estimate for the value pi. We know it's too small. Okay. Now what we're going to do is we're going to go back and count the area differently, trying to keep track of these squares here that have any part of the circle inside them. Now we're going to overestimate that because these squares have part of their squares outside the circle. So that's going to be too big of an area, but it'll hopefully balance. We've got one area that's too small, one area that's too big, and we can kind of meet in the middle with an average here. So to get the what we call the out area, what we're going to do is we're going to count all the squares that have any part of the square inside the circle at all. So not just all of them inside, but any part in the circle. So that would be all of these and all of these plus all of these plus all of these. So if I count these, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So in this quarter circle, there's 22 squares that have any part of them in the circle. And as we go down, there'll be 22 in the upper left, 22 in the lower left, 22 in the lower right quadrants. And so overall, that would be 88 squares on this piece of graph paper that have any part of the square inside the circle. Right. So my overestimate for the area, my area that I know is too big, is going to be 88. And so I'm going to take that area and I'm going to calculate a value for pi. That is the pi out. And again, I'm going to take that area of 88 squares and divide that by the radius squared, or 88 divided by 25. And that's where we get that number in the write-up. 88 divided by 25 is 3.52. Okay. So since that's 3.52, our estimate for pi using the outer area is 3.52. And we know we've got too much area, so we've got too big of a value for pi. But again, hopefully by taking a underestimate and an overestimate for the values, we can average those together to get our value for pi that hopefully be pretty close. Now, just to give you a heads up, if you're using a full sheet of graph paper, you got a big circle there, then your radius is going to be probably something like, I don't know, depending on the size of your squares, maybe 15, maybe 20, 25, something like that. And you're going to have a few hundred squares when you do that, right? So going to take a lot more counting, but you'll get a lot better results if you use a bigger circle. So the next thing we want to do is we want to take these two and average them together. Remember, average them together means you add them up and divide by 2, right? So I'm going to take 2.40 and 3.52 and add those together. So I can make that look a little bit more like a 3. And then we're going to divide that by 2. So 2.4 and 3.52 is what? 5.92 that I'm going to divide by 2. And let me not try to do that in my head. And oops, I didn't do that right. That's 2.96. And so that's where they come up with the average value for pi here of 2.96 by averaging the inner value and the outer value. Hopefully, again, if you're using a larger circle with more squares, you'll get a better estimate for that. But that 2.96 is a lot better than the 3.52 or the 2.40. It's closer to what we expect it to be, which is a 3.14159 on. So the other thing that's a part of this is finding the range. In other words, how close are our measurements given us as we do this? And basically the way we get the range is we're going to take our, actually let me use a different color for this to kind of set it off. So for the range, we want to do one of two things. We can either take the big value for the pi and subtract the average, or we can take the average and subtract the small value that we had. That's a little bit easier math, so I'm going to do that. So take the 2.96, the average value, and subtract off the smaller value of the 2.40. And that, if you take that, that's 0.56, right? So that's where in the example they come up with 0.56. What that means is, what we've done is, you can do the same thing if you take the large value, the 3.52, and subtract 2.96, you'll also get 0.56 from that. And so what it is the two values we found for pi are within 0.56 of the value we want to use from our little measurement, which is 2.96. So what we would say the range is 0.56. And so right here, I want to put my average value plus or minus that range, meaning our two measurements are somewhere between 0.56 bigger than 2.96, which is that number, and 2.96 minus 0.56, which is that number right there. All right. So with our little circle, we've come up with an estimated value for pi between 2.9 or of 2.96 with a range of 0.56 like that. Okay. All right, so that's the first part. Again, hopefully you'll get better results using a bigger circle with more squares. It'll take you a little more time because you got to do some more counting. Don't forget to square the radius when you're doing this bottom here, but you'll do it exactly the same way, just with different numbers. All right. For the second part, what you're going to do is you're going to take the idea that pi is not only related to the area of a circle, but that pi times the diameter of a circle, let's see, use a D, yeah, D for the diameter, is equal to the, sorry, hold on just a minute. Okay, like I was saying, we know that pi times the diameter of a circle is equal to its circumference. And so if we're trying to find pi, and pi would be the circumference divided by the diameter. That's just another thing you can do to find pi, right? If you measure a circle's circumference and divide it by its diameter. So we're going to do that with two different objects. The lab write-up suggests you use a quarter or something small like a quarter, something small like that, and then you use something larger. The larger, the better. So if you have like a big dinner plate or a big trash can or something like that, something that's a circle, but is basically the biggest circle you can find, right? And so what you want to do is pretend I've got a circle right here. You want to measure the diameter, which is the distance across the widest part of the circle, or from one side through the center to the other side like that. And then you want to measure the circumference of the circle. So you want to start at one point on the circle and measure all the way around like that. So this is your diameter, and this would be your circumference. If you have like a seamstress's tape measure or some kind of flexible tape measure, you can use that, wrap it around the circumference. Or if you've got a piece of string, you can wrap a piece of string around it. If it's something like a quarter, you can also like try to roll it across a ruler and see how long it takes you to roll one complete roll around. That'll also give you the circumference, and then measure the diameter as best you can. Well, let's suppose you take a ruler and you measure this diameter here, and it turns out to be 2.5 inches. So let's say we'll use, just pretend I used a lid, say, for instance, for this, and it was 2.5 inches. And then I measured, sorry, that's the circumference. I'm saying the diameter is 2.5 inches. And then for the circumference, say I took a piece of string and wrapped around it and saw how long that string was, and that measured out to be 8.0 inches. Okay. So what I'm going to do is I'm going to take the circumference and the diameter for this one object, and I'm going to divide them to get my value for pi. And so there's space down here for you to do some calculations. So my value for pi is going to be 8.0 inches divided by 2.5 inches. When I do this, the inches divide out, so I don't have any units on this. And if I do that arithmetic, it works out to be 3.20. Okay, so that would be the value for pi from this, 3.20. And then to do the range, there's a couple ways you could do it. What the lab suggests is that you say, okay, let's suppose I went one more mark on my ruler, and I said, okay, for the circumference. And so instead of 8.0, let's say it was 8.1. And let me take the 8.1 and divide it by the diameter. So and see what that would give me for pi. So if I went one mark more, right, so I was a little bit off in that. It was 8.1 instead of 8.0. And I divided that by 2.5. It's going to be a little bit bigger number, 3.24. And that would be a value for pi if I was actually needed something a little bit bigger. And so the difference of those two would give me my range. So if I subtract 3.24 That's 3.20. That's 0.04. That would be my range for that particular measurement, right? And so the range would be 0.04. Okay. All right, and then same thing with the second object. Again, use something small like a quarter or the lid to a bottle or something like that for the object number one, and try to use something big like a big dinner plate or big trash can or something like that for object number two. Okay. And if you do that, then that'll give you these results. There is a couple of questions at the end of the write-up. Let me see if I can go back to that. Not here. That would be here. Not there either. I'll get it in just a minute. So there's a couple of questions at the end of the write-up, and there's space at the bottom of the very end of the data sheet for you to answer these questions right here. All right. And that would do it. Hopefully that helps, gives you a little bit more idea of what it is that you'll be doing for the lab. And if you got any questions, just drop me an email.